Okay, last time we had our product rule and quotient rule. Remember, there are never rules or shortcuts for adding and subtracting. Okay, the only way you can add and subtract things, combine things, is if they're exactly alike. Okay, it doesn't matter if these are x, they might as well be x's. I don't know what square root of 5 is. I mean, I know it's 2 point some non-ending number. So think about what we do. Think about what we do if this would have been 3x plus 7x. Oh, that's just 10x. Right? The variable part stays the same. So that's what this is saying. Oh, I have 3 of these square root of 5 things plus 7 more of those same things. So altogether I have 10 of those square root of 5 things. Right? I can only combine things that are exactly the same. 5 markers and 2 markers, 7 markers. 5 markers and 2 erasers, just 5 markers and 2 erasers. So over here, these are the only ones I can combine. Okay, so 2 of these square root of 11 things minus 1 of the square root of 11 things. 2 minus 1 is 1, so I have a square root of 11 thing. Plus 3 square roots of 44. Now, as it stands right now, I'm done. Unless, oh, remember, radicals are just like exponents or fractions or anything. We got to simplify them. Whether I can add it together or not, I got to simplify this. So remember what I'm going to do. I'm going to make this 4 times 11, and 4 is 2 times 2, just to see if I can simplify it. So that makes this, the rest of the problem stays the same, plus 3, 2 squared times 11. 2 goes into 2 one time, so I can bring a 2 out. And nothing is left over. Well, except for the 11, right? 2 doesn't go into 1 at all. Oh, but look what that means. So this is square root of 11 plus 6 square roots of 11. Hey, one of these plus 6 more of them, all together, 7 square roots of 11. So the only way I can add or subtract, combine radicals, is if they're exactly the same. And just like variables, the index has to be the same and everything inside has to be the same. Okay. These things are not the same. So right now I can't add them. However, I got to simplify them regardless. So 12 I can write as 3 times 4. And 4 is 2 times 2. All right, so this can be changed to 5 times the square root of 2 squared times 3, and then don't forget we still have that y under there. All right, 75, I can make 3 times 25, and then that's 5 times 5. Okay, so plus 6 square root of 3 times 5 squared times y. Okay, now the index is 2. 2 goes into 2 one time, meaning I can bring a 2 out with none left over. But this has an exponent of 1 and 1, so they're just going to stay inside there. Okay, I got a 6 outside already. This is going to stay inside because the exponent's a 1. But 2 goes into 2 one time, so I can bring 1 5 out, and there's nothing left over. So the 3 stays in here and the y stays in there. Which is okay because now look, they're both square roots of 3y. They're exactly alike. So this is 10 square roots of 3y. And this one is 30 square roots of 3y. So 10 of them plus 30 of them all together gives me 40 of them. Okay? This one won't simplify any further. And this one won't either, because I would need an exponent bigger than 2, or as big or bigger than 2 on one of these. Since these are not the same and I cannot make them the same, I cannot combine them. Okay, they're not the same, so I'm going to simplify. Okay, I hope we know by now that 32 is 2 to some power, right? So without having to spread it all out, let's count them all. I'm counting my fingers. 2 times 2 is 4, 8, 16, 32. That's 2 to the 5th. All right, 162, okay, is 2 times 81. So hopefully we'll kind of get used to what these values are and do them a little simpler. You can always go back and do the entire prime factorization, but I know that 81 is 3 to the 4th because it's 9 times 9. Okay, so 4 goes into 5. This -2 is just out here. 4 goes into 5 one time, meaning I can bring a 2 out, but there's 1 left inside. Okay, this won't simplify because it's just to the first power. But 4 goes into 4 one time, so I can bring a 3 out. And it goes evenly, so there's nothing left inside except for that 2. All right, so now this is just math outside that I can do. And these are the same. The index is the same. So if I have -4 of these things, and I'm going to take away 21 of the same things, that's it's not -21. That's -25 of the same things. Those 4th root of 2 things. Okay. 3 goes into 4 one time, but there's 1 left over. 3 goes into 7 2 times with 1 left over. Now 64, I need to simplify. Well, 64 is 32 times 2. So let's do our 2's again. I'm counting on my fingers again. Right? 2 times 2 is 4. 8, 16, 32, 64. That's 2 to the 6th. Or you could go through the whole process of your prime factorization. Okay, now this thing I'm still in the process of simplifying. So I've got PQ squared, cube root of PQ. 3 goes into 6 2 times, so I can bring 2 2's out. And it goes evenly, so there's no 2's left over. All right, so I've got PQ PQ squared, times the cube root of PQ minus 4 times the cube root of PQ. Now be careful. This is exactly the same, the cube root of PQ and the cube root of PQ. But PQ squared and 4, I would need all of my variables have to be identical, variables and exponents. I don't have a PQ squared over here. These can't be combined any further. Even though the radical part is the same, the entire variable part has to be identical. Okay, just one more. Okay, so 16, again, let's do our 2's. On my fingers, 2 times 2 is 4. I'm holding up 2 fingers. Times 2 is 8. Times 2 is 16. Okay, so this is 6 times the cube root of 2 to the 4th z to the 7th plus 4, okay, times the square root. Oh, I'm never going to be able to combine. It doesn't matter, I got to simplify them anyhow, but they're not going to combine, right? One's a cube root, one's a square root. But I still got to simplify it. So 200, since we got room over here, let's go over here and do 200, is 2 times 100. And this is 10 times 10. So 5 times 2, 5 times 2. So this is 2 cubed times 5 squared times z to the 5th. 3 goes into 4 one time with 1 left over. 3 goes into 7 2 times with 1 left over. Okay, this is a 2 now, so 2 goes into 3 one time with 1 left over. 2 goes into 2 one time with nothing left over. 2 goes into 5. I'm going to make that a little bit tighter. 2 times 5. Two goes into 5 2 times with 1 left over. Okay? So now this is 12 z squared cube root of 2z plus 8 times 5 is 40 z squared square root of 2z. So the variable part is all exactly the same. I got a z squared, got a z squared, 2z under there, but I got a 3 here and a 2 here. So I can't go any further. Okay, I'll see you next time.